Alright, so here's the equation from question number 3 in lesson 3, and it asked you to count up how many of each atom is on each side, and I think everybody made at least one mistake, and this is a really hard problem, so I want to make a video and show you guys how to do it. This is something that we learned like 5,000 years ago before school ended, so you've seen this before, but hopefully this helps make sense so that when we start balancing equations next week, reading them will be a little bit easier for you. So most people seem to remember that these little numbers here are the subscripts, or maybe not what they're called, but you guys remembered how to use them. So a lot of people were able to look at like C6H12O6 and figure out that that's 6 carbon, 12 hydrogen, and 6 oxygen. But the part that threw people off was these bigger numbers here, which are called the coefficients, just like in math. And just like in math, just like how if you had like 6x in math, that would be 6 times x. 6 CO2 means there's 6 of those CO2s. So to show you guys another example, a simpler example of that, this 6O2 here, sorry, there we go. So the 6O2 here, that means there are 6 O2s. So if you remember that O2 means that we have 2 oxygen molecules bonded together. 6 O2 means there are 6 of those. So I've drawn out 6 of these. And if we count all of these up, that would be 6 times 2 is 12. So if you wanted to, you could draw out the picture. I'm just kind of doing it as an example. You can think of it like math. We have a coefficient times another number, so 6 times 2, that would be 12 oxygen. So keeping that in mind, let's go ahead and try to count all of these up together. So what the question was asking you to do is to count the number of every element on both sides, and both sides is, we have the left side over here is the before the reaction happens, so these are our reactants. And then the right side is after the reaction happens, so these are our products. So we're counting up the number of each element on both sides, and I'm going to erase these words here so that we can count. And if you guys remember, the reason we need to do this is because these are really the same atoms. These 6 carbon over here are these same 6 carbon over here. They're just getting rearranged. I think I'm actually going to show that first before we count them up. I want to show that since I can draw for you guys. So I'm actually going to show drawing the atoms later because this equation, I don't know why they started with this one. It's really complicated. If you guys recognize it, this is the photosynthesis equation you guys learned about in biology. It's pretty complicated. So I'm not going to draw out the picture just yet, but I will. We're just going to count them up since that's all that lesson 3 asked us to do. And I'll make another video that's maybe a little bit more polished when we actually start balancing to show you guys how to balance. So our left side over here, we have carbon. Make what I'm drawing with a little bit bigger. So we have carbon, we have hydrogen, and we have oxygen. And on the right, we also have carbon, hydrogen, and oxygen. So all we have to do in this problem is just count how many of each there are. So this 6 right here tells us that in this glucose molecule, there are 6 carbon. This 12 here, I'll make that a different color. This 12 here means that there are 12 hydrogen. And then the part that even people who got this far got tripped up by is that we have oxygen actually in 2 places. We have oxygen here and we have oxygen here. So there's some oxygen that's by itself. That's those 6 O2 molecules I drew out earlier. And then we have these 6 oxygen that are here. So we act in the glucose molecule. So we actually have 6 oxygen plus another 12 oxygen. So in total, that gives us 18 oxygen on the left. And I don't know if maybe like 1 or 2 people got that. Almost everybody who got this far got tripped up by the fact that there's oxygen in 2 places. And this is, again, probably one of the hardest equations to be starting this with. So don't, like, that's why I'm trying to make a video, because I totally know that not everybody was there yet. And there's a lot of review in these assignments, so we'll go over this again, and we'll have a lot of practice before you guys have to balance equations on your own. So over here, we have 6 CO2, and so what's tricky here that we have to keep in mind, I'll draw it down here, 6 CO2, remember that the subscript only affects the oxygen, but this coefficient affects everything. So we would have 2 times 6 is 12 oxygen, but we're only going to have 6 carbon because this 2 doesn't affect the carbon. So we have 6 carbon here, and so far that looks good. It's the same on both sides. And remember, again, those are the same 6 carbon atoms. They're just breaking these bonds and rearranging to make something else. That's why these numbers have to be the same, because this is before and after of the same stuff. So let's do hydrogen next, actually, because oxygen, again, we have oxygen in 2 places, so it's going to be pretty hard. So hydrogen, we can kind of ignore this oxygen and H2O and just look at this part for right now. We have 6 H2, so we could draw out 6 H2 like I did with the 6 O2s, or we can know that this tells us 6 times 2 is 12. So we have 12 hydrogen, which is the same as the left side. And then oxygen, again, is tricky once more because we have to look at all of the oxygen, not just this oxygen here and not just this oxygen here, but we have to add up both of them. So over in the CO2, and our 6 CO2, that's going to be a lot like our 6 O2s, except they're all attached to carbon, and I could actually, I won't show you guys that, but, so 6 times 2 gives us 12 oxygen here, and then for our 6 H2O, I'm just going to rewrite it down here because I'm running out of space. For our 6 H2O, we already counted up the hydrogen that's here. 6 times 2 gave us 12 hydrogen, but every one of those is a water molecule, right? Like you guys know from biology, we have an oxygen and 2 hydrogen. So we have 6 of these. We have this whole thing times 6. So if we have 6 water molecules, we would have 12 hydrogen total because there's 2 in each one. And then we're going to have 6 oxygen total because there's 1 in each molecule. So we have 6 water molecules, 6 times 1, we can kind of think of it that way if you want to use the same math each time. Gives us 6. So we have 12 oxygen in the CO2, in all those 6 CO2 molecules, and we have 6 total in the 6 water molecules. So if we add those up, we have 18 oxygen, just like on the other side. So this equation is balanced because we have 6 carbon, 12 hydrogen, 12 hydrogen, 18 oxygen, 18 oxygen. This plus 6 is not, it's about the oxygen molecule down here, not that 18. So, it was kind of hard for me to explain this without having you guys in front of me to tell if you have questions or not. It's weird talking to a video. But if you have questions about this, you can just message me in chat or post in the chat area and I will answer them. And if you guys come to office hours, I can do this live with you and walk you through problems. So I'll make more videos when we learn how to balance equations. And I hope this was more helpful than it was confusing. It's not great that this problem is, it's a very, very hard one to start, but you guys have done a great job with some really tough assignments so far. I'm really proud of everybody. Keep up the good work. We're almost done. Bye.